Hello and welcome to BYJU'S Exam Prep. Welcome to another episode in our knowledge series where we shall be talking about the topics of El Nino and La Nina. Now both these features, that is El Nino and La Nina, these are the conditions which we end up observing in the region of southern equatorial Pacific Ocean. But in turn, they have their climatic ramifications experienced across the globe. And even in India, the amount of rainfall that we receive during the monsoonal months, that is heavily dependent upon whether the condition is that of an El Nino or that of an La Nina. So that is why it is important for us to understand what these actually are. When we say that a condition of La Nina is prevailing, or if the condition has gone to an El Nino, what do we actually mean by that? So first of all, in this video, we shall be understanding the three different phases of El Nino, La Nina and the neutral conditions. And then we shall also try to understand their impact on India in terms of the amount of rainfall we receive during the monsoon months. So we start with, first of all, understanding the entirety of the term that is actually encapsulated as ENSO. ENSO stands for El Niño-Southern Oscillation. So basically, as I just now told you, it is an event which unfolds itself in the southern equatorial Pacific. Not in the lower ends of the Pacific, but exactly below the region of equator. So around that area, you have the heating and warming as well as the cooling of the oceanic waters of the Pacific taking place, thereby creating a difference in sea surface temperature between the eastern as well as the western Pacific ends. As a result of this difference in temperature, we also end up experiencing a difference in pressure conditions. And those pressure conditions eventually end up driving climatic factors and climatic circulations across the globe. So overall, it is a recurring climatic pattern involving changes in the temperature of waters in the central as well as the eastern tropical and southern equatorial Pacific Ocean. Now, as you can observe from the animation here, the conditions, they do oscillate between three states. Either that will be a condition of La Nina, or under normal circumstances in majority of the conditions, the thing that we experience is referred to as the neutral condition. Or sometimes the condition might also twist to the side of El Nino. So because it keeps on oscillating between these three states, and every 3 to 7 years the conditions tend to revert back, that is why the term oscillation is used. Now, first of all, we shall understand what are the conditions or what is it that we experience during the neutral phase, what is it that we experience during the La Nina phase, and what is it that unfolds itself during the El Nino condition. So we start with the neutral phase. So in this neutral phase of circulation, which is something that we observe under normal circumstances, under general circumstances, the conditions that we observe, that is referred to as the neutral phase. It is also sometimes referred to as the Walker circulation or the Walker cell, after the much famed mathematician, that is Sir Gilbert Walker, who actually was also at one point of time the director of Indian Meteorological Department in the early 1900s. Now, what Gilbert Walker came across is the fact that around the region of equatorial Pacific, because Pacific is a very large ocean and Pacific is a kind of a homogeneous territory as well, not much of land masses, not much of territories in between. So as a result of that, the winds that blow in the equatorial region, they end up gathering some speed. And when these winds, they gather some speed, they are able to carry the surface water along with them. Now, which winds are we talking about? We are talking about the trade winds. Now, these trade winds, what is their general direction of movement? Their general direction of movement which is observed is in the northern hemisphere from northeast to southwest, whereas in the southern hemisphere from southeast to northwest. In general, around the equatorial region, we can observe, or we can basically say that the trade winds, they push the waters from, in general, the eastern direction to the western direction. That is, from the coastlines of South America to the region around northern Australia. That is the general movement of surface water which is observed. Now, we know something about the surface temperature of oceans. The surface temperature, especially around the equatorial and the tropical regions of oceans, that is the highest which is observed. As you start going into the depth of the ocean, the temperature starts reducing. So, in the equatorial region, when we say that the surface water is being taken away by these trade winds, we basically end up signifying that the warmer waters, they are being carried away. Now, slowly and steadily, all the surface warmer waters from the equatorial region, they are carried over to the region of Western Pacific. And in the area of Western Pacific, we observe in general an accumulation of warmer waters. Now, because you have warm waters in the region of Western Pacific Ocean, that automatically creates a condition of a low pressure. And low pressure is basically because of the thermal factor, right? Because of high amount of warm water getting accumulated there. So the air above this low pressure, that will also get heated up because of the influence of the warm water. After getting heated up, the air simply begins to rise. As the air begins to rise, eventually it will hit the region around troposphere or the top of troposphere, that is tropopause, and that air will end up diverging. One part moves to the west, another portion moves to the east. Now, like this, the air which moves in the upper atmosphere eventually does sink down around the region of Eastern Pacific Ocean and thereby completes a circulation. This circulation that is achieved, that is also what is referred to as the Walker circulation. The Walker circulation. Now, this Walker circulation is in existence under normal conditions. Whenever you have the normal conditions, when the air pattern, the movement of the winds, they are not disturbed because of certain anomalies, this is the condition that you end up experiencing. Now here, what do we observe in terms of climatic factors? In the region around Western Pacific, we observe the creation of a low pressure. Now that creation of a low pressure will induce the action of convectional process, and thereby it will lead to formation of clouds and bring about a very heavy bout of rainfall in the region around Indonesia, Philippines, and also sometimes northern portion of Australia. So the western part of Pacific will receive heavy rainfall under the normal conditions of ENSO. Whereas when we take a look at the eastern part of Pacific, here something very interesting unfolds itself. As the winds, they take away the surface water slowly and steadily. Slowly, the subsurface water gets exposed to the surface. The subsurface water is generally colder, always. And as a result of that, you have here an accumulation of a colder water region. Here you have the accumulation of cold waters. Where do these cold waters come from? These are the waters which are directly underneath the surface but are slightly cooler than the surface. So these come up, and as a result of that, this creates a slightly cooler condition aided by the subsiding wind, and that creates a condition of high pressure. So the region around Eastern Pacific will experience a conditionality of high pressure. And whenever you have a conditionality of high pressure, that means dry conditions. And you will have absolute lack of cloud formation whatsoever, and it will be a kind of a dry weather climate and dry weather condition which shall be experienced. So this is what happens in the neutral or the normal conditions. And if you look at the overall climatic pattern or the overall atmospheric circulation being induced by it, you can always have an understanding that in the region around the Western Pacific, you do have the creation of this low pressure. And as a result of this low pressure, the winds will rise, form very dense cumulonimbus clouds, resulting in very heavy rainfall. Whereas in the region of Central and Eastern Pacific, you will have sinking air column creating dry conditions. Now, these are the neutral or the normal conditions. Eventually, as you have the presence of warmer waters in the region of Western Pacific, these warmer waters, they will start attracting more winds. Why? Because of creation of low pressure. Whenever you have any low pressure anywhere, that will always end up attracting large quantum of winds. Why? Because winds always blow from a high to a low. So winds will always blow towards that low pressure. So these warmer waters, they will start attracting more winds. And as more and more winds are driven towards that warm water region, those winds will start carrying more amount of surface water along with them. As a result of that, the accumulation of warm water, the pool of warm water in the Western Pacific, that tends to increase. This becomes significantly larger, and then the wind velocity also significantly increases. As a result of that, when the wind velocity in the form of these trade winds, they get very, very strong, what happens? There is significant amount of surface water which is carried, means there will be subsurface water, as you can observe, which will come to the surface, thereby reducing the sea surface temperature. The sea surface temperature in the eastern part of Pacific, that is something which will reduce. It will become colder. Okay? So, the low pressure intensifies itself, the high pressure further strengthens itself. In a way, we can say it is the strengthened form of the normal cycle or the Walker circulation. But this is what is referred to as the phase of La Nina. So that is why this phase of La Nina is also said to be an intensified neutral phase, or it can also be referred as intensified Walker circulation. So most often times you will observe that basically a normal circulation, a normal condition eventually intensifies itself into a La Nina condition. La Nina is what makes the Western Pacific much more low pressure in the terms of its intensity. But if you look at the overall Pacific Ocean, the central and the eastern part, you will observe that the proportion which is occupied by the cooler waters, that is increasing. The warmer waters, yes, they are concentrated in the western part, but you have a large swath which is actually occupied by the cooler water. So that is why the condition of La Nina is also referred to as the phase of cooling of Pacific Ocean. So when we say cooling of Pacific, we are talking about here again equatorial and tropical Pacific, and that too in the region of southern hemisphere, and hence the name Southern Oscillation. So here what do you observe? That the region to the north of Australia around Indonesia, Philippines and the entirety of the South Asian territory, they will experience very intense low pressure. As a result of that, you have excessively heavy amount of rainfall which is received, and that heavy amount of rainfall can also induce flood-like conditions. So many portions in the region of northern Australia, many of the island territories in the Southeast Asian region, they experience flood-like conditions during La Nina. Whereas when we talk about the western coast of South America and the entirety of the eastern Pacific Ocean, because of the very strong high pressure, you have absolute lack of rainfall, and you experience a kind of dry drought-like conditions. Now, lack of rainfall, why will it lead to dry drought-like conditions? Because this phase of heating and cooling of Pacific is something which materializes or peaks during the months of November up till February. And during these months, if you analyze carefully, it is the summer season in the southern hemisphere. While it is winter in the northern hemisphere, it is summer in the southern hemisphere. And during the summer season, if you have an absolute lack of rainfall for a prolonged duration, drought-like conditions can always be experienced. So that is why you have frequent drought-like conditions experienced in the region of eastern part of Pacific Ocean. Now, this La Nina circulation also has a kind of an atmospheric cell which is created in the entirety of the region. And you will experience that here you have the active low pressure. As a result of that, much stronger wind movement as compared to the neutral condition and much significant amount of rainfall in the entirety of the zone. Whereas you will have a sinking air column and a cooler water region almost in the entirety of the central and the eastern Pacific Ocean. Just remember this fact that La Nina is also referred to as the cooling phase of the Pacific, and that is because the central and the eastern part of the Pacific, they observe cooler water temperatures. Now, these are the conditions when you have neutral phase intensifying into La Nina. But what do we mean by El Nino? What is it that unfolds itself during the conditions of El Nino? So during El Nino, first of all, what is observed is that these trade winds which were driving the warmer waters under normal circumstances during La Nina conditions, but in general the trade winds which were driving the water from the east to the west, these trade winds, they start weakening. So whenever you have the trade winds weaken, so weakening of trade winds, sometimes you can also have the trade winds completely absent in a certain portion. Sometimes you can also experience in small localized areas the trade winds reversing their direction. Now, why does this happen? Why is it that the trade winds will weaken themselves? So that is because of host of different contributing factors, including the role of ocean currents, as well as in general the weakening of the high pressure zone in the subtropics which drives these trade winds. And that happens because of warming of the Pacific Ocean. So when you have the warming of the Pacific Ocean, in general, you have the subtropical high pressure zones which are an origin point for these trade winds. Those high pressure zones, they start weakening. As a result of that, the trade winds, they also start becoming much significantly weaker. When these trade winds become weaker, there is no force anymore which is present to drive these waters in the region of Western Indian Ocean. As a result, what happens? All that accumulated warm water from the Western Pacific all that accumulated warm water from the Western Pacific, that accumulated warm water, it starts flowing back. So all that accumulated warm water, it will start flowing back in the Pacific itself. And eventually, these warm waters will reach somewhere in the eastern portion of the Pacific. Now, once these conditions are achieved, once you have the flow back of warmer waters from the Western Pacific all the way to the Eastern or the Central Pacific, then you have the shifting of the low pressure. The low pressure which earlier existed in the region of Western Pacific now has come over to the region of Eastern Pacific. Now, this low pressure will start attracting winds from all directions, all different directions. As a result of that, surface waters shall now be carried over to the region of Central and Eastern Pacific. Here, the air will also get heated up, it will also get warmed up, it will rise, forming convection clouds and causing very heavy and very dense rainfall. Eventually, you will have a complete circulation which is achieved, whereby the air will be sinking now in the region of the Western Pacific, creating a kind of a high pressure here. So, El Nino conditions can also be referred to as the reversal of the Walker circulation or the reversal of the normal conditions. Under these conditions, the region around Eastern and Central Pacific observes a low pressure, because of which you have very high amount of rainfall, heavy rainfall. In fact, regions around Peru, they also experience flood-like conditions. Whereas, when we consider the region of Western Pacific, they are very, very dry. Particularly impacted is the region of Australia, where during El Nino years, we have widespread occurrences of forest fires and bushfires because of extraordinarily large spells of dry conditions. So this is a significant reversal of the condition, and it is a phase which is referred to as the heating or the warming of the Pacific Ocean. Now this El Nino, if you look at the overall circulation and also the sea surface temperature, you will observe that now you have warmer waters in the region of the Central and the Eastern Pacific, which earlier in the normal and La Nina conditions were occupied by cooler waters. So as a result of that, you have rising air column in the region of Central and Eastern Pacific, and eventually you have the whole circulation which is achieved. This El Nino condition is achieved primarily because of either the weakening or the reversal or sometimes the complete absence of trade winds which are present. Now, when we talk about all these three phases, we know that what happens in the region of Eastern and Western Pacific Ocean. We know that under which phase, under which condition the Western Pacific receives rainfall, under which condition the Eastern Pacific receives rainfall. Now, we'll look at the impact on the Indian monsoon. So all these three different phases. As you can observe, again I'll take you back to the previous figure. In all these circulations, you will observe a kind of a low pressure or a high pressure ramification also created in the region of Indian Ocean because of what happens in the Pacific. So what happens actually is that these ENSO circulations or these ENSO cycles, they have an impact on Indian monsoon. Whenever you have a condition of El Nino, that El Nino is always going to be detrimental to the amount of rainfall received in India during the monsoon months. So El Nino brings about drought-like conditions in India. Drought-like conditions in most of the circumstances, but in general, they bring about a lack of rainfall during the monsoon months. What about the condition of La Nina? So La Nina will bring about a condition of excessive rainfall, excessive rains in India, especially during the monsoon months. And what about the neutral phase? So neutral phase is also favorable for rainfall. So even during the neutral phase, the quantum of rainfall that you end up receiving is going to be significantly greater than average. Overall, La Nina as well as neutral conditions, they are beneficial for India in terms of the amount of rainfall received, whereas El Nino is slightly disadvantageous or detrimental. But having said that, one thing that we have to keep in mind is, as is true for any fundamental concept of climatology, no event acts in isolation. So even these ENSO cycles, their impact on India, that can always be involved and can also be counteracted by various other features and events which unfold themselves in the Indian Ocean. So we have features such as Indian Ocean dipole. We have features such as Madden-Julian oscillation, which can always end up counteracting the impact of El Nino and La Nina in terms of Indian monsoon. The case in point was driven during the season of 1997 and 1998, where Actually, the intensity of El Nino was predicted to be the strongest in the past century. So India was well prepared for a very severe drought-like condition. But then eventually it was found out that yes, we did receive rainfall slightly lesser in comparison than the previous year, but the rainfall was nowhere clearer to the drought-like conditions. And that was because the conditions of positive Indian Ocean dipole that counteracted the impact of El Nino. So we have to understand that while each one of them will have their own impact on Indian monsoon, they can always be either counteracted or supplemented by the impacts created by Indian Ocean dipole, jet streams, as well as Madden-Julian oscillation. So that is all that you need to know about this topic. This is mostly important for the examination in terms of your prelims as well as mains, because slowly and steadily with the global warming having caught up with an increasing pace, we are experiencing more features of El Nino and more frequent recurrence of El Nino, and that is something that we need to be careful about in India. So now let us take few of the questions. So one question is, why do trade winds weaken during El Nino? So one of the reasons for the weakening of the trade winds is basically because of the weakening of the subtropical high pressure belt which drives these trade winds. Now why will the subtropical high pressure belt weaken? Because of the warming of the Pacific. So this warming is achieved over a duration of 2 to 3 years. As a result of that, even the Peru or the Humboldt current, which is a cold current, that also slows down. But as soon as the water starts coming to the eastern part, automatically the trade winds normally have to reverse their direction. That is why. Now, what is El Nino Modoki? El Nino Modoki is basically a kind of modification or a type of El Nino where rather than one complete cell, you have two cells in circulation, where you have the low pressure created in the region of the central Pacific and you have two convective cells which are created. So in this case, you have high pressure conditions experienced at both ends of the Pacific, whereas low pressure is experienced in the central Pacific. Then does Coriolis force affect El Nino? Coriolis force won't impact El Nino to the extent, but if you have to put in the role of Coriolis force somehow, just look at the movement of the trade winds. The trade winds themselves, they embody the role of the Coriolis force. And these trade winds, they move from northeast to southwest and southeast to northwest, owing to the role of Coriolis force. So it is because of this Coriolis force that the trade winds, they gather a general east to west direction. Otherwise, they would simply be moving from north to south and not leading to any of these phenomena. Then another question by Akshay. What is exactly causing the flowing back of warm water from the west to east Pacific? Okay, Akshay, basically what happens is that, understand, under normal circumstances, even during La Nina condition, a continuous blowing of the wind, that will keep the warm water accumulated. Imagine with the help of an experiment of a glass or a bucket which is full of water right up till its very brim. Now suppose here on the side of it, you put a fan in circulation, let's say, and the fan is moving, giving the wind towards that water. You will find that the water ends up accumulating at one end. But as soon as you switch off the fan, what will happen to the accumulated water? Will it remain accumulated any longer? No, it will start flowing back. So under similar circumstances, when the trade winds which were keeping the accumulated waters present in the Western Pacific, when those trade winds either disappear or they weaken, all that accumulated water, eventually they also end up gaining a height gradient of around 5 to 7 centimeter in the region of Western Pacific. So that 5 to 7 centimeter of height increase because of accumulated water, that provides the potential energy, and that entirety of the water column rolls back. Okay? Does pollution and human-made factors impact El Nino and La Nina very much? In the sense, if you look at it, then basically, yes, anthropogenic factors create a kind of global warming, and that global warming is something, and that climate change, the rising sea surface temperature, all of that makes the condition of El Nino much more frequent. And even when La Nina occurs, the La Nina is also much stronger, which can also lead to later monsoonal floods in India. Sometimes you will experience that during the months of September, certain regions in Maharashtra, certain parts in Andhra Pradesh, certain parts in central India, they get flooded. And that is because of increased intensity of La Nina as well. So yes, you can have an impact because of global warming and climate change, but still it is being studied in order to understand the exact quantification of the impact of human-based activities on these global atmospheric events. So that is all from our side today, and I hope this helped you understand the topic regarding El Nino and La Nina. And if you like the video, please click on the like, share and subscribe button. Thank you.